Good morning, good afternoon, and good evening. Welcome to dclessons.com. Today we are going to present Module 4, Nexus Fabric Module. Now, the Nexus Fabric Module are like a backplane of Nexus series switches. Now, why it is used and where it is used, what is the significance of its uses? When we connect all line card, all supervisor from a front, right? These line cards and these supervisor engines are interconnected to each other via fabric module. Now the traffic between ingress and egress line card, they must pass through the fabric module. So let's suppose if any traffic enters to the module 1, right? And it wants to go to the module 2, 3, 4, 6, 7, any egress module, they have to cross to the fabric module. Why? Because fabric module acts as a backplane of your Nexus switches, right? So we can say that fabric module are like meeting point of all Nexus line cards and supervisor module. So there are two types of fabric module generation 1 and fabric module generation 2. Now the generation 1 fabric module, they supports on Nexus 7010 and 7018, and it provides 46 Gbps per slot, right? And maximum number of line fabric module we can insert is 5. On a fabric module generation 2, it can be used on 7009, 7010 and 7018, and it produces 110 Gbps per slot, and maximum number of fabric module we can insert is 5. So this one is basically for Nexus 7000 series switches, right? Now when we talk about Nexus 7700 series switches, right, only the fabric module which is supported is fab 2, fabric module generation 2, which is supported on 7706, 7710 and 7718 supported chassis. It provides 220 Gbps per slot bandwidth, and we can interconnect 6 fabric module in a chassis, right? So total bandwidth per slot, right, we will see there is a mathematical calculation, right, through which we can understand that if we fully populate our Nexus box, right, in terms of line card, in terms of supervisor engine, and in terms of fabric module, how much my Nexus series switches have a maximum throughput, how much total bandwidth my backplane can support. Tricky. So that is why I see these emoticons is thinking how it happens, right? Now let's see how it works. So let's suppose there is a fabric module, right, and a line card. They are interconnected. So for each line card there will be a 2 trace, right, going to each fabric module, right? So 2 trace, 2 trace, 2 trace, 2 trace, 2 trace, fabric module, fabric module, fabric module, fabric module, fabric module. 2 is your generation. So for each line card, 2 trace per fabric module. Now per fabric module, 2 trace, so there are 5 fabric module, so total trace will be 10 trace. So 1 2 3 4 5 6 7 8 9 10, like that. Also here also 10 trace will be there. Now let's suppose this is your supervisor engine. So for supervisor engine there will be only 1 trace per fabric module. So soup engine supports 5 trace, and because we are using fabric module generation 2, each trace will have a bandwidth of 55 GB, right? So 55 GB per trace. So all together they will support 110 GB per second. Okay, now let's calculate. So one line card, 10 trace, right? Now if I'm using 7010, so it has a 8 line card. So 8 line card into trace, so there will be 80 traces altogether. Now one supervisor engine has 5 trace, so there will be a 2 supervisor engine. So we'll have a 2 into 5, that means 10 trace. Total number of trace will be 80 plus 10, 90 trace. Now each trace has a 55 GB of bandwidth. So 99 trace, how much it will be? 90. 90 into 55, it will come across 4950 Gbps half duplex. So for a full duplex, it can support 9.9 or we can say 10 terabyte per second. So see, for a full duplex operations, when your Nexus box is fully populated with the line cards and with the supervisor engine and all the fabric module with the generation 2, and that is on the Nexus 7010 chassis, it can support around approximately 10 terabyte per second. So for each second, it can be able to process 10 terabytes of packet. See how enhanced performance it has. I am talking about only on Nexus 7010 module. But if you talk about 7009 or 7018, obviously your bandwidth calculation and your throughput calculation may vary because your number of traces may increase in when we use 7018, or it may decrease when we use 7009, right? Now let's talk about what is VOQ. VOQ is a virtual output queuing. So it is a virtual queuing technique, right, which is used to prevent a backplane congestion, right? So when a traffic has to go from one module to another module, right, it will check whether the egress module, egress port, egress queue has a spaces or not. If it has a space, then only your ingress module will be allowed to send your traffic from egress module, from ingress module to egress module via backplane, right? So this VOQ also solve a problem like, let's suppose here in the diagram, there is a stadium and there is a mall, and some traffic wants to go to the stadium, but some traffic wants to go to the mall or a school, we say. But because most of the traffic is going to the stadium, the car which is going to mall, they cannot go through it. Why? Because the car which is going to take a route on the stadium, they have blocked the path, right? So that is called a head of line blocking, right? So head of line blocking is a issue in which some of your traffic, they won't be passed until and unless it all frontline traffic will not get passed. To solve this problem, what happened, we created a two type of queue, two type of path, we can say, or two type of queue. So all those cars which needs to go to the stadium, they will take a Q1, and all those cars who want to take to the mall, they will take a Q2. So there will be no congestion for all or any red cars. So this is how we can solve here head of line issue. Okay, now another problem is also, there is another solution. We can enhance this problem in a better way to introduce a arbiter, right? Now let's suppose that I have used arbiter on a uh, in front of my queue, and I have an arbiter which is there on a stadium, right, which is watching the stadium traffic, right? Now let's suppose the car is going, and they are parking, and stadium is getting slowly and slowly its occupancy is increasing. Now once the stadium is full, then your arbiter will inform to the arbiter which is there in front of your queue that boss, stop allowing cars. So this man or this arbiter will not allow any car to go inside, right? And due to which they will solve the head of line blocking. There will be no space, so there will be no car allowed, right? If there is a space in a queue, then a car will be allowed, else stop it, right? In the second case, we see that arbiter is informing to the arbiter in front of a mall road that supermarket is not full, please allow the cars, and the cars is allowed, they are going inside, right? So VOQ is used to solve the HOL issue, head of line issue. Now how does it works in terms of Nexus 7K, right? So following are the steps used by VOQ for proper working of its operations. Now in this step first, what happens, each of the line card, right, each of the line card will share its egress port VOQ status to the supervisor and to the ingress module. So let's talk about that. Module 2, module 3 are the egress module where your traffic will go out, whereas module 1 will be the ingress module where source is connected. Now what happens, the module 2 and module 3 will share its egress port, right, VOQ status to the supervisor module, right, and also to the ingress module. So ingress module will have the egress buffer for module 2 by 3. So let's suppose there is a destination connected to 2 by 3, and here it is connected to a 3 by 2. So 3 by 2 VOQ and 2 by 3 VOQ status are shared with the ingress module. So they will have a status of each egress port on a egress module. So this is a first step, right? Each module informs the supervisor about the egress buffer available to them for each port group, as well as they will share their own egress buffer information to the ingress module also, correct? Now the second step will be, as soon as your source sends a traffic, right, to the ingress module, your ingress module will see the L2 lookup or L3 lookup, right, to see where I have to send the traffic. It will determine that I will have to send the traffic on a module 2. Why? Because module 2 is that module where your destination is connected. Now what happens, it will store the packet in its VOQ, right? Then it will ask a permission to the supervisor module, which we say as an arbiter, right? It will ask that, boss, I want to transmit a packet from port 1 by 1 to port 2 by 3, right? The supervisor module will already have module 2 2 by 3 egress port queue status. It will see that, okay, this queue space is free, I mean the TX space is free on a port 2 by 3, let's grant it. So it will grant the permission, right? As soon as the arbiter grants the permission to the egress module, ingress module will transmit this packet, and it will take any of the fabric module and it will reach to the module 2. Then from module 2 it will go to the 2 by 3 port TX queue, physical queue, and from the TX queue of 2 by 3 it will go out, right? So if the egress buffer is available on a port E2 by 3, then a supervisor will grant permission to the ingress module and deduct one credit available to the egress buffer, right? So one credit will be deducted here, that because I am using this space. Now the frame will be transmitted from ingress module to the egress module via crossbar fabric. When egress module forwards the frame to the physical port, right, it will inform to the supervisor module, and supervisor module will remove this credit. So it will say that now I have the full buffer available, right, for that port. Make sense? So this is how your VOQ works, right? The main function of the VOQ is to avoid or prevent packet drop in the egress queue of the egress port of the egress module. Egress queue of the egress port means egress queue of egress port of egress module. Egress module is module 2. Egress port will be E2 by 3 and 2 by 3 of its TX port, so physical port. If there is no space or no buffer available for the TX, right, on the 2 by 3, the arbiter or a supervisor will not grant, right, the access, and your packet will be stored in a VOQ, right, in on a ingress module. As soon as your supervisor will grant a permission that okay, port 2 by 3 TX buffer is available, your ingress module will send the traffic, it will reach to 2 by 3 TX port, and TX port will finally send the traffic outside, and as soon as it will send packet to the outside, it will inform to the supervisor module. Supervisor module will deduct the credit, and which indicates that the buffer for 2 by 3 port is available. Now I can again process the traffic. So this is how your VOQ works. Thank you for watching module 4 Nexus Fabric module.